Well, hi everyone. I got simplifying trig expressions. I want to get started here using the conditions tangent of x equals 1/3 and cosine of x is I think I want to change that. Cosine x is, I want that to be negative to make it more interesting. I meant to have that negative. Cosine of x is less than 0. Find all the values of all 6 trig functions. So we know from the Pythagorean identities, we need to find all 6. And I know 1 plus tangent squared theta is equal to secant squared theta. I'm going to use this at x here, so I'll use x here. And tangent of x is 1/3. So if I go 1 plus 1/3 squared, that'll equal secant squared of x. Now, that's 1 plus 1/9 equals secant squared x, and then that's 10/9, which equals the secant squared of x. Now, if I take square root, I got a plus or minus. I got plus or minus square root of 10 over 3. Square root of 9 is 3, is equal to secant of x. Now, cosine is negative. That means secant is also negative because the reciprocal. So I'm going to go with the secant of x is equal to negative square root of 10 over 3. And that the cosine of x is the reciprocal of that, which is negative 3 over square root of 10. And let's rationalize that denominator. That's negative 3 radical 10 over 10. And then let's see. Well, I'm going to do cotangent of x is 3. We know tangent of x is 1/3. We just need the sine. I'm going to use sine squared x plus, and there's different approaches here. I'm going to use another Pythagorean identity here. Sine squared x plus cosine squared x is equal to 1. I do know we're going to need the negative for that, but so sine squared x plus negative 3 radical 10 over 10 squared, that's cosine squared x, is equal to 1. So sine squared x plus, if I square that, that's 9 times 10 over 100, which is 90 over 100. So that's 9/10. When I square this, I get 9/10 is equal to 1. Negative 3 squared is 9. Square root of 10 is squared is 10, and 10 squared is 100. So I get sine squared. So sine squared x is equal to, if I subtract, is equal to 1/10. If I subtract 9/10 from both sides. And I take the square root, and I get a plus or minus. I'm getting the sine of x is equal to plus or minus 1 over square root of 10. And we know it's going to have to be the negative one. We know that because sine over cosine is tangent. And if cosine's negative, then sine's got to be negative because the tangent is positive. We probably could have maybe done it a little easier just using the ratio, but you have choices here. I'm going to multiply that by the square root of 10 over square root of 10, so I'm going to use the negative here. Negative square root of 10 over 10. So the cosine, I already knew. I don't have this very organized here, but the sine of x is negative square root of 10 over 10. The cosecant of x is the reciprocal of that, which is negative 10 over the square root of 10. If I multiply that by the square root of 10 over square root of 10, well, I could have just, okay, I'm not using my head very well here. That's negative 10 radical 10 over 10. And those will cancel out. So I'll put that there. The cosecant of x is negative square root of 10. All right, so there's all 6 values. This isn't the only way you could have approached that. Now I want to simplify cosecant squared x, cosecant x minus cosecant of x. Now when I can factor. I'm going to factor out cosecant of x from these two, and I have cosine squared x minus 1. This is the approach I take first here on this one. Cosecant of x times cosine squared x minus 1. Now remember, sine squared x plus cosine squared x equals 1. And if I would subtract cosine squared x from both sides here, I'd have sine squared x equals 1 minus cosine squared x. Okay, now if I multiply both sides by negative 1, then I've got negative sine squared x equals negative 1 plus cosine squared x. That's the negative 1, that's the positive cosine squared of x. So this is the same as cosine squared x minus 1. So I'm going to replace cosine squared x minus 1 with negative sine squared x. I'm going to write cosecant x as 1 over sine x times negative sine squared x. Forgot to write the x there. Now, one of these will cancel out with one of those, so I end up with negative sine x. That's a simpler version of what we have here. Okay. This one, we want to factor. I'm going to use the identity for secant squared x. 1 plus tangent squared x is equal to secant squared x. We have that identity for our Pythagorean identity. I'm going to take, because I have tangent here, I'm going to take this, I'm going to replace it with 1 plus tangent squared x. I add 3 tangent x plus 1. So now I've got tangent squared x plus 3 tangent x plus 1 and 1 is 2. Now, we can do the u thing here. Let u equal tangent of x if you want. And you would be factoring u squared plus 3u plus 2. And that's u plus 2 times u plus 1. And then put the tangent back in. And that's tangent of x plus 2 times tangent of x plus 1. I have factored it now. If that's a little easier for you to see, you can do that. If you're good just going from here to here, you're thinking of tangent of x as just kind of its single term, that's good too. So it's up to you. Now, I'm going to perform the addition here and simplify. I need common denominator. This has 1 minus sine theta, this one does not. So I'm going to take 1 over 1 plus sine theta times 1 minus sine theta over 1 minus sine theta plus 1 over 1 minus sine theta, and multiply that by 1 plus sine theta over 1 plus sine theta. Now, I need to sharpen my pencil. It's starting to look like Ben's midterm right now. Okay, so I'm going to make that top 1 minus sine theta. I'm going to make the bottom here 1 times 1 minus sine theta. First, outside, inside, last. If you remember, this is like difference of squares. The outside and inside are going to cancel out. Negative sine theta and positive sine theta. So we have 1 minus sine squared theta here. And then I have 1 plus sine theta over, again, 1 minus sine squared theta. Let's add the numerators. That's my common denominator right now. 1 plus 1 is 2. Negative sine theta plus positive sine theta cancels out. So it's just 2 over 1 minus sine squared theta. All right. And remember, sine squared theta plus cosine squared theta is equal to 1. If I subtract sine squared theta from both sides, I've got cosine squared theta equals 1 minus sine squared theta. All right, which is what this is. So this is equal to 2 over cosine squared theta, which is pretty nice, but I'm going to go even further than that. That's 2 times 1 over cosine squared theta, which is 2, and 1 over cosine squared theta is secant squared theta. This is 2 times secant squared theta. All right, this next one, rewrite cosine squared theta over 1 minus sine theta so that it is not a fraction. All right, cosine squared theta, we've done this a couple times. That's 1 minus sine squared theta, and that's over 1 minus sine theta. I'm going to factor this difference of squares here. That's 1 plus sine theta times 1 minus sine theta over 1 minus sine theta. Those will cancel, and that is 1 plus sine theta. All right, one more here. We're going to use the substitution x equals 3 sine theta, where theta is between 0 and pi over 2. We've got a domain for theta here. To write square root of 9 minus x squared as a trig function of theta. So I'm going to take 9 minus, and I'm going to replace x with 3 sine theta. Which is the square root of 9 minus 9 sine squared theta. And I'm going to rewrite that as, I'm going to do this. I'm going to factor out a 9. And this is 1 minus sine squared theta. I'm going to factor out the 9. That's the square root of 9 times the square root of 1 minus sine squared theta. Which square root of 9 is 3. I got this somewhere, don't I? Cosine squared theta is 1 minus sine squared theta, so it's 3 times the square root of cosine squared theta. Square root and square cancel out, so that's 3 cosine theta. And that is that, guys. All right, take care, and God bless you.